Chapter 3, Section 6, using the quadratic formula. Using the quadratic formula. Have any of you ever heard of the quadratic formula or seen it before? Okay. We'll look at it here in a second then. Using the quadratic formula. So here is our quadratic formula. You need to have this written down. Let A, B, and C be real numbers such that A is not 0. The solutions of the quadratic equation, ax squared plus bx plus c equals 0, is this formula right here. This is our quadratic formula.
You want us to write that?
You need to write it down. Do I need to write it bigger or can we see it? Okay, I'll write it bigger. X equals negative b. We say that's the opposite of b. Because if our b value is negative, it's going to become positive. If our b value is positive, it's going to become negative. So the opposite of b, plus or minus the square root of b squared minus 4ac. All of that over 2a. X equals the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. You need to have that written down. This is the quadratic formula. This is just another way for us to solve a quadratic equation. Okay? So we've learned lots of ways to solve quadratic equations. This is just another method to solve. So once again, let A, B, and C be real numbers such that A does not equal 0. The solutions of the quadratic equation, ax squared plus bx plus c equals 0, are x equals the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. So we get our a, b, and c values from our quadratic equation. A is in front of x squared, b is in front of x, c is our constant. So like I was telling someone earlier, we're just identifying values to plug in the numbers to our formula. Okay? This is our quadratic formula. Does everyone have the quadratic formula written down? Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Can I move on? Yes. Solve x squared plus 3x equals 5 using the quadratic formula. X squared plus 3x equals 5 using the quadratic formula. Is this equation in this form right here? No. Well, how is it not in that form?
Because the 3 is on the same side as x, and then x is squared.
So x is squared. We want x to be squared, right? I want it to be ax squared plus bx plus c equals 0. Do I have everything on the left-hand side and then 0 on the right-hand side? No. So what do you think I need to do to get it in that form? Subtract 5 from both sides. Can 5 combine with anything on the left-hand side? No. So I just write x squared plus 3x minus 5 equals 0. Is this now in that form, ax squared plus bx plus c equals 0? Yes, it is. There's my quadratic formula, right? It tells me to solve using the quadratic formula, so let's solve it. What I'm going to do first is identify A, identify B, and identify C. So remember, A is multiplied by x squared. So what number is being multiplied by x squared?
3x.
What? 1. There's no number in front of my variable. It's understood to be 1, right? So I know my A value is 1. Everyone okay with A being 1? Okay, my B value is multiplied by x. What's my B value? 3. My C value is my constant. What's my C value? -5. Everyone okay with that? Everyone okay with how I've identified A, B, and C? Now all I'm doing is plugging these values into my quadratic formula. Anywhere I see an A, I replace it with 1. Anywhere I see a B, I replace it with 3. Anytime I see a C, I replace it with -5. We okay plugging in? So, X equals the opposite of B. So what's my B value? What's the opposite of 3?
-3.
So I get -3 plus or minus square root of B squared. So I get 3 squared minus 4 times A, which is 1, times C, which is -5. That's all under the radical. Over 2 times A, which is 2 times 1. Is everyone okay with how I plugged in? Anytime I saw an A, I replaced it with 1. Anytime I saw a B, I replaced it with 3. Anytime I saw a C, I replaced it with -5. We okay with that? Now I just got to work it down. Order of operations. There's a lot going on here, but we can do it. So X equals -3 plus or minus. What's 3 squared? 9. What's -4 times 1? -4, and then -4 times -5.
20.
Positive 20, right? So that just turns into plus 20. Did I skip too many steps, or are we okay with that? And what's 2 times 1? 2. Questions there? Okay. -3 plus or minus. What's 9 plus 20? 29. All over 2. Can I do any more simplifying, really? No. Square root of 29 is just going to stay the square root of 29. Because there's no other perfect squares that go into 29, are there? So I can't simplify that square root. I can't do any simplifying with all 3 of my numbers outside the radical, because the only number that goes into -3, 1, and 2 is just 1. So it's just going to stay like that. So my 2 answers are X equals -3 plus the square root of 29 over 2, right? If I wanted to get the decimal, I could type that in my calculator. So I would get -3 plus square root of 29 over 2. I would get approximately 1.19. There's one of my solutions. Another solution would be X equals -3 minus square root of 29 over 2. I type that in my calculator. I would get -4.19 approximately. So there's my 2 answers. Any questions how I got that? So like I said, we're just identifying values, plug them into a formula, get into our answer. Are these real or imaginary numbers that I have as answers right here?
Imaginary.
They have an I value in them?
Pretty much.
They're real numbers, right? So I have 2 real solutions here.
They got fake equal signs.
Nope. I got 2 real solutions here. Questions on example 1? Can I move on?
Yes.
Example 2. Solve 25x squared minus 8x equals 12x minus 4 using the quadratic formula. That doesn't look like that form on my first slide, does it?
No.
No, so what do I need to do?
Get your options on the same side.
Get everything to the same side, right? And then my right side equals 0. So how do I move that 12x from the right to the left? Subtract 12x from both sides. Will 12x, negative 12x combine with anything?
Yeah.
Yeah. What's negative 8x minus 12x? Negative 20x equals negative 4. Is that in that form yet? No, I need to get everything over there, so what do I need to do? What do we say back there? Add 4 to both sides. Will my 4 combine with anything? No. We okay with that? Not too bad? Is that now in the form?
Yes.
Yes, it is. So, since it's in that form, I can go ahead and do what? Say what?
Put in the quadratic form thing.
Identify A, B, and C, and then plug into my quadratic formula. So in this case, what's my A value? The number times x squared. 25. What's my B value? The number times x.
Negative 20.
-20. And my C value, my constant,
Positive 4.
+4. We okay with that? Now I can just plug in to my quadratic formula. What is the quadratic formula?
Negative b
Opposite of B,
plus or minus
plus or minus,
radical
square root,
9
B squared,
minus
minus
4ac
4AC, all over 2A. Anytime I see an A, I'm plugging in 25. Anytime I see a B, I plug in negative 20. Anytime I see a C, I plug in 4. So the opposite of B, what is my B value?
Negative 20.
-20. What's the opposite of negative 20?
Positive 20.
So I get 20 plus or minus square root negative 20 squared minus 4 times 25 times 4 all over 2 times 25. Everyone okay with how I plugged in? Okay. I get 20 plus or minus square root. What's negative 20 squared? So negative 20 times negative 20.
40.
Not 40.
200.
What?
Negative 100.
Not negative 400.
Positive.
Positive 400. Negative times a negative gives me a positive. Negative 4 times 25. What?
Negative 100.
Negative 100. Negative 100 times 4.
Negative 200.
Negative 400. All over, what's 2 times 25?
50.
50. Everyone okay with that? What's 400 minus 400? 0. What's the square root of 0?
0.
0, right? So I get 20 plus or minus 0 over 50. Is there a difference between 20 plus 0 and 20 minus 0? No. So this just is 20 over 50, which reduces down to what? Two-fifths, right? How many solutions do I have here? One. Because I had plus or minus 0, but plus 0 and minus 0 are the same thing, right? So I just have one solution here. Is it real or imaginary?
Real.
It's real. Got one real solution here. X equals 2/5. Questions there? We good with example 2? We okay with quadratic formula so far? It's just plugging in numbers and working it through a formula. Example 3. Solve negative x squared plus 4x equals 13 using the quadratic formula. Is that in that special form I needed in?
No.
No, I need everything to the left and 0 on the right. So how would I get everything to the left and 0 on the right here? Subtract 13 from both sides. Will negative 13 combine with anything?
No.
Nope. Is this now in the special form I needed in?
Yes.
Yes, it is. So let's identify A, B, and C. What's my A value here? My number times x squared?
-1.
-1. Am I moving too fast for anybody? I can slow down if I need to. What's my B value here? My number times x? 4. And my C value? C is -13. So now I can start plugging into my quadratic formula. X equals the opposite of B plus or minus square root B squared minus 4AC all over 2A. There's my quadratic formula. Opposite of B, what's my B value here?
-4.
Opposite
4.
4. So what's the opposite of positive 4? So I get -4 plus or minus square root of 4 squared minus 4 times -1 times -13. All over 2 times -1. We okay with how I plugged in?
Yeah.
-4 plus or minus. What's 4 squared?
16.
16. What's -4 times -1? Positive 4. Positive 4 times -13. -52. All over. What's 2 times -1? -2. You okay with that? Going further. -4 plus or minus square root. What's 16 minus 52? -36 over -2. What's the square root of -36?
6.
Just 6?
-6.
-6. 6. Well, 6 times 6 would give me positive 36, not -36.
But 6 times, well, -6 times next is positive 6.
Did we forget how to take the square root of negatives?
I did.
Huh?
I did.
What? I can break it up into -1 times 6, or -1 times 36, right? What's the square root of -1?
1.
One.
-1.
I. What's the square root of 36?
6.
6. So it would be 6i.
Oh.
With nothing left under the radical, because I took the square root of everything.
So
Right?
that'd be question.
Yes.
So when you square root of negative, it'll be I.
Yep. If you take the square root of negative, you get I. Something I. Or I square root something.
And so we're gonna need.
Okay. Can I reduce anything here?
Yes.
What are -4, 6, and -2 all divisible by?
2.
2. So -4 divided by 2.
Goes 2.
-2 plus or minus 3i over -1. Everyone okay with that? So my two answers are x equals -2 plus 3i over -1. Or if I divide -2 by -1, I'd get 2. 3i divided by -1 would be minus 3i. Everyone okay with that? I just divided my -2 by -1 here. Gives me 2. 3i divided by -1 gives me -3i. And negative 2 minus 3i over negative 1. Negative 2 divided by negative 1 is 2. Negative 3i divided by negative 1 would be plus 3i. So there's my two solutions. Questions on example 3?
What is the same answer?
So up here, I get negative 2 plus 3i over negative 1. So I can break up the plus and minus, right? So here I just divided these two by negative 1 because that's what's happening. So negative 2 divided by negative 1 is positive 2. 3i divided by negative 1 is negative 3i.
Okay.
Here, it's negative 2 minus 3i over negative 1. So divide negative 2 by negative 1, I get 2. Negative 3i divided by negative 1 is plus 3i. So how many solutions do I have here?
2.
2. Are they imaginary or real?
Real.
Imaginary.
Imaginary. They got eyes in them, right?
Yeah.
Any questions on that? So we saw 2 real solutions, we saw 1 real solution, and we saw 2 imaginary solutions. We okay with that?
Yeah.
Can I move on? Okay, analyzing the discriminant. In the quadratic formula, the expression that's under the radical, b squared minus 4ac, is what we call the discriminant of the associated equation, ax squared plus bx plus c equals 0. So in our quadratic formula, like I said, it's the expression that's under the radical, b squared minus 4ac. We call that the discriminant. You can analyze the discriminant of a quadratic equation to determine the number and type of solutions of the equation. So before I even find the solutions, I can use the discriminant to determine how many solutions I'm going to have and if they're real or imaginary. Okay? So does everyone have written down that the number under the radical, or the expression under the radical, b squared minus 4ac, is called the discriminant? Everyone got that written down? We put b squared minus 4ac is the discriminant. The number under the, or the expression under the radical, b squared minus 4ac, is called the discriminant. We use it to tell how many solutions we have and what type of solutions they are. It determines how many solutions we have and what types of solutions they are. So either real or imaginary. And our options are going to be 2 real, 1 real, or 2 imaginary. Everyone have what they need down for discriminant? Okay, let's move on. Okay, here's a little chart right here. I would write this down if I were you. I would write this chart down. Here's how we analyze the discriminant. So once again, we want it in this special form. Ax squared plus bx plus c equals 0. So our discriminant is b squared minus 4ac, right? So if the value of my discriminant, b squared minus 4ac, is greater than 0, so it's positive, if my discriminant is a positive number, I know I'm going to have 2 real solutions. So I'm going to have 2 x-intercepts. It's going to be crossing my x-axis twice. Okay? If the value of my discriminant equals 0, so I get 0 under the radical, I get 1 real solution. It's only going to hit my x-axis once. It's going to have 1 x-intercept. And then if the value of my discriminant is less than 0, so if it's a negative number, and I'm going to have 2 imaginary solutions, it's not going to cross my x-axis at all. Okay? So I would mainly focus on those 2 things. My discriminant's greater than 0. If it's positive, I got 2 real solutions. The value of my discriminant equals 0. Got 1 real solution. If the discriminant is less than 0, negative, I got 2 imaginary solutions. And once again, when my graph crosses the x-axis, those are solutions to my quadratic equations. So if I have 2 real solutions, it's crossing twice. One real solution that's crossing the x-axis once. Two imaginary solutions, it's not touching my x-axis at all. We kind of okay with the discriminant? It'll probably help once we see it in practice. See it with an example. We have written down what we need written down.
No.
Okay, I'm waiting a second. So if it only asks for how many solutions you have and what types of solutions they are, I don't have to worry about the whole quadratic formula. I just have to worry about doing the discriminant. B squared minus 4ac. Does that make sense? Now if it actually tells me to find the solutions, then I do have to use the quadratic equation, quadratic formula. But if it just asks for the number of solutions and type of solutions, all I have to do is the discriminant. Okay? Okay, I'm going to move on real quick. I can come back to this slide if I need to. It says, find the discriminant of the quadratic equation and describe the number and type of solutions of the equation. Does it tell me to actually find the solutions?
No.
No. So all I have to worry about here is the discriminant. What is the discriminant?
X, b squared minus 4ac.
B squared minus 4ac. That's all I have to do. If it's greater than 0, I've got two real solutions. If it equals 0, I've got one real solution. If it's less than 0, I've got two imaginary solutions. Okay? So letter A. Let's identify A, B, and C again. What's my A value on letter A?
1.
1. The number times x squared is 1. What's my B value here? The number times x, negative 6. My C value, my constant,
Good.
10. Everyone okay identifying A, B, and C from our equation?
Good.
Okay, let's plug these into our discriminant. So B squared, got negative 6 squared minus 4 times 1 times 10. That's my discriminant, right? B squared minus 4ac. Negative 6 squared,
36.
36. Negative 4 times 1,
Negative 4.
negative 4. Negative 4 times 10,
Negative 40.
negative 40. 36 minus 40,
Negative 4.
negative 4. Is negative 4 greater than 0, less than 0, or equal to 0? Less than 0. So if my discriminant is less than 0, how many and what type of solutions do I have? Two imaginary. So for letter A, I would say there are two imaginary solutions.
This equation in particular.
Questions on letter A? Does everyone understand what we're doing?
Yeah.
Like I said, if it told you to find the solutions, I would then have to plug in to my quadratic formula and get the two solutions. But it doesn't tell me to do that, so that's all I have to do. Questions on letter A? Can I erase letter A and move to B? So we finished letter A. Let's do letter B. What's my A value for letter B? 1. What's my B value for letter B?
Negative 6.
-6. And my C value?
9.
9. Plugging these values into B squared minus 4AC, my discriminant, I get -6 squared minus 4 times 1 times 9. B squared minus 4AC. -6 squared gives me
36.
36. -4 times 1,
Negative 4.
-4. -4 times 9.
36.
-36, right? 36 minus 36 gives me
0.
0. Is 0 greater than 0, equal to 0, or less than 0?
Equal.
Equal to 0. So if my discriminant equals 0, how many and what type of solutions do I have?
One real solution.
So I would say there is one real solution for letter B. Questions on letter B? Does everyone see how we're determining how many and what type of each solution we have?
Yeah.
Can I erase and move to C? So we're done with B. Now we're on to C. What's my A value on C? 1. What's my B value on C? -6. They just like to use -6 for B, don't they?
No.
What's my C value?
8.
8. Plugging those into B squared minus 4AC. Get -6 squared minus 4 times 1 times 8. Just like the other two, what's -6 squared? 36. -4 times 1. -4. -4 times 8. -32. What's 36 minus 32? 4. Is 4 greater than 0, less than 0, or equal to 0? Greater than 0. So if my discriminant is greater than 0, how many and what type of solutions do I have?
2 real solutions.
2 real solutions. So I'd say there are 2 real solutions for letter C. Questions on how we're using the discriminant? We determined how many solutions we have and what types of solutions they are. Questions on example 4? Shh.
So if it's greater than 0, then it's 2 real solutions?
Yep. My discriminant's greater than 0, got 2 real solutions. If it equals 0, I got 1 real solution. If it's less than 0, I got 2 imaginary. Okay? Can I move on from example 4? Okay. This is my last slide. I just wanted this to have I wanted to have this up here. These are all the methods that we've talked about of solving quadratic equations, right? If you want to write this down, you can, so you know when to use which method. Okay? So, when to use graphing, we use when approximate solutions are adequate. Okay? Because when we see a graph, we can't always see exactly where it's crossing the x-axis, so we have to approximate it a little bit. Using square roots. Use when solving an equation that can be written in the form u squared equals d, where u is an algebraic expression. Factoring. Use when a quadratic equation can be factored easily. So if I see a quadratic equation and I think to myself, oh, I think that can be factored pretty easily. Factor it and solve the equation using factoring. Using your zero product property. Take each factor, set it equal to 0. Completing the square. This can be used for any quadratic equation. Ax squared plus bx plus c equals 0. So I can use it for any quadratic equation in that form. But it's simplest to apply when a equals 1 and b is an even number. That's the simplest ways to apply it. And then the quadratic formula. If all else fails, you're not sure which method to use the quadratic formula. That can be used for any of our quadratic equations. You can use it for literally any single one of them. Okay? If all else fails, use the quadratic formula. Is anyone writing this down? Okay, I'm waiting. I would recommend having this written down.
Wait, we did the last 5 days of notes to do the same problem.
Say it again.
We went the last 5 days of notes to figure out how to do the same problem 5 times differently.
Well, these are the when to use them. So I'm not going to use each of these methods on every single problem. There's just best times to use these methods. There's just different ways to solve quadratic equations.
Just
So we got graphing, we got using square roots, we've got factoring, we've got completing the square, and we've got the quadratic formula.
No, I didn't know to do it. It's kind of dark.
I would recommend having it written down, or I guess take a picture of it.
Journey's just copying. You see
Did anyone miss anything from my previous slides that I need to go back to? Are we okay?
No.
picture of Dawson's head?
No.
Never know.
Is
Okay.
it enough to where you can-
We've got about 6 minutes left of class. I'm going to give you your assignment tomorrow in class. No homework tonight.
Oh, I thought you said
Um,
assignment. I was about to say.
So make sure you come prepared to work tomorrow in class. Bring your book or your laptop, whichever you use for your textbook.
Yeah, this is.
Are there any questions about my notes before I end the recording?